Today we would like to discuss SolidWorks on the 3D Experience platform and how such an environment can benefit your company. Many companies today have successfully deployed PDM systems to manage their design documentation. They have pushed these systems to maximize their use within the design process. But you eventually find yourself asking the same questions that are beyond your system's capabilities, such as, how can I reduce errors between design and engineering? Can I collaborate better with users beyond the design department? Can I work directly with my suppliers in the design process locally and globally to streamline development? Can I leverage enterprise IP such as material compliance, requirements, and project management within my design process? If your answer is yes to any of these questions or questions like them, then you should look beyond PDM to a product lifecycle management system. Let's contrast these two environments. Much like apples and oranges are both fruit, PDM and PLM systems are both systems managing IP, but that is where the similarity ends. PDM, or Product Data Management, provides workgroups an environment that manages and synchronizes design data for product development. It extends the reach of product design IP into engineering and manufacturing collaboration, as well as the security of design IP. PLM, or Product Lifecycle Management, provides an environment that manages the product produced by an enterprise where the focus of the system is on the items or parts and resulting BOM structure required to define the product. This discussion so far has been at a fairly high level, so we will work our way back down. Let's talk about working with ENOVIA as a designer in SolidWorks. The infrastructure that supports ENOVIA is flexible and scalable, allowing a large number of configurations for a local, national, or global deployment. In this example, a corporate data center resides in the Northeast, where a single copy of the database exists. 6 remote sites would tie to the system, where 4 of these could be design centers indicated by the local file control servers at each of these locations. This configuration would allow optimal performance for the designers while remaining remote to the data center. All services within this infrastructure use HTTP for communication to the client platforms, further increasing the flexibility of the system's use in the field. Such networks are imperfect, however, so the system is able to operate in online and offline scenarios. Let's now get down to the ground level and take a look at the application itself. There are 2 client-side components that make up the SolidWorks connection, which integrates SolidWorks with the 3D Experience platform. The first is a Windows Explorer add-in, which allows the designer to manipulate design data directly from the desktop. This allows the designer to continue to work in a file-centric paradigm. Designers can review information and work with managed files in the same fashion as they would with unmanaged files. Designers can explore data in a familiar Windows environment. Here we see the designer browse the folders and managed files via Windows Explorer. The folders are displayed with different graphics to indicate they contain files associated to the management system. As you can see, working with the managed file in the folders is not any different than if PLM was not controlling them. The user can get detailed information about a component without leaving the Windows environment. Note that the designer uses the SolidWorks functions in the same manner as they would in a file-based environment. Here, the designer browses and locates an unmanaged assembly and places it into a session. Browsing for components is quite natural. PLM also brings database power to the desktop via a flexible search engine. In this example, the user adds a new part using a familiar method but types a few characters in the search criteria to locate the component quickly. Any combination of attributes can be used, as well as the attributes may be altered for different users or departments. The connector also expands the visual capabilities of Windows Explorer by allowing the user to see the full structure of the designs to quickly access the parts in context. In this example, the Contains tab exposes the underlying assembly structure. The designer alters the display by switching to Content to expose thumbnails of all the subassemblies and components. Designers can also access all data related to the design from both the file and PLM system via the desktop in a common and familiar way. Here we see the designer altering their display to include some attributes unique to the PLM system. Any combination can be made on a per-user basis, and columns may be dragged and dropped in any order. Preview capabilities are prevalent throughout the Windows Explorer, as we have seen. As we saw earlier, the structure can be fully exposed. The Explorer window also incorporates the familiar e-drawing viewer with all the functionality the designer has become accustomed to directly in the window. Preview capabilities extend beyond Windows into the web client, where enterprise users can explore any type of decision design data with a single viewing application. This eliminates the need for enterprise users unfamiliar with a particular CAD viewing solution to master multiple viewers for different types of data. The second client component of the SolidWorks connector is embedded directly within the SolidWorks application. Since this product was developed by SolidWorks R&D, they utilized our existing and successful EPDM application as the basis for this new tool development. You have already noted the similarities. Commands are available in multiple locations in the interface, so that commands can be available regardless of which pieces of the interface the designer turns off. Great effort has also been made to limit the intrusion of the management system into the designer's environment. Only those PLM commands that are pertinent to a designer are made available. Looking at the command bar, we note the usual check-in, check-out commands. Additional commands such as Show Card, History, and Explore in ENOVIA round out the basic functions. As noted in prior examples, ENOVIA seeks to minimize PLM overhead within the design process. In the process of design data, it is necessary to quickly determine information about the design components without leaving the design environment. The connector provides the functionality to access and load any prior version of a design, as well as review data on the design in a session. The designer may also review the history of the design. All this is possible without leaving SolidWorks. The connector also includes more advanced functionality that builds on your IP by leveraging knowledge from within the PLM system. The copy structure command is a good example. Here, the designer can select an existing assembly and use it to create a derivative design. The designer simply selects those components they wish to make copies of in the structure and builds an entirely new assembly reusing instances of prior components. Once selections are made, the user can use a number of different renaming features provided by the tool to quickly establish new names for the components. Here, a prefix is being created for all the new derivative components. Once the naming has been established, the designer can select a destination folder for the new components and complete function. Here, we see 3 new components that were created. These have been linked to the existing managed components that were used from the original assembly. Opening the new assembly into session, the new unmanaged components are noted, and the designer may begin their changes. SolidWorks data can also be organized with other types of files in the same folder. Here, the designer opens a separate Windows Explorer session and drags and drops some additional files into the folder with some existing SolidWorks components and checks them indirectly from the SolidWorks add-in. Let's wrap up with a quick overview of the platform that supports the SolidWorks connector as well as all the other enterprise-level applications. This functionality connects you to the enterprise via a common environment called the 3D Experience Platform, which focuses on leveraging all value in your enterprise into the design process as well as bringing IP to all users and decision makers. The 3D Experience Platform does not stop here as it reaches into many other peer disciplines within the enterprise, such as simulation and business intelligence. Thus, it is a business experience platform that provides software solutions across every organization in your company, from marketing to engineering to sales, to help you create differentiating consumer experiences. Based on the value of running such a platform, let's summarize some of the values in using the ENOVIA connector of SolidWorks to drive your design process. We saw that core product management capabilities can open the door to more extensive PLM tools directly from the design application. We saw that efficient and immersive CAD data management is accessible from anywhere there is a Wi-Fi connection. By offering a common platform design and engineering data, the management of an EBOM structure in context of the CAD data, changes can reduce the errors and overall process, with extensions to Enterprise PLM. Building on this last value, we can see where such a tight relationship between design and engineering can further promote a design-to-configure mentality in design due to direct BOM relationship. Thank you for your time, and we hope this short presentation gave you some insight into the value of designing on a true PLM platform. Since we only scratched the surface, please feel free to contact us for further information and more detailed presentations on any specific facet of the SolidWorks connector, as well as all related applications available on the 3D platform.